Welcome back, Java and Spring Boot developers, to today's Explainer. We are unpacking a seriously critical piece of architecture for building robust, enterprise-grade AI systems, and that is AI Fabric. Specifically, we're taking a fascinating look at how to handle modes, positions, and orchestration policy to completely secure the context of your production AI endpoints. Okay, let's dive into this architecture.
So here is our blueprint for this explainer. We're going to cover the AI endpoint dilemma, define positions and modes, map the ownership boundary, and look at orchestration policy and precedents. Then we'll cover concrete flows and failures, and finally wrap up with a prod O2 lab bridge.
Section 1. The AI Endpoint Dilemma. Securing Production AI Context. Now you might be wondering, what's the actual dilemma here? Well, the absolutely crucial architectural point is this. A production AI endpoint cannot, under any circumstances, expose identical capabilities across every surface of your application. Think about it. A knowledge page, it's designed to retrieve approved support articles. That's a purely read-only operation. It must never be able to create a support ticket. On the flip side, a ticket workspace might pull that exact same evidence, but it also needs a governed write operation to actually log the ticket. Even then, it can only do so after proper server authorization. If you just blindly expose the same AI endpoint to both surfaces without strict boundaries, you're opening the door to some massive security risks.
Section 2. Defining positions and modes. Distinct, not interchangeable.
Let's start with position. What exactly is it? Basically, a position is your application context. So in a support knowledge assistant, the position knowledge literally just means the user is reading help content. The position ticket means they're actively working in a support resolution surface. The biggest takeaway here is that these names belong entirely to your application. Another app might use completely different terms, like catalog or checkout, right? But most importantly, an application position is not an authorization claim. Just because a browser sends a request claiming it's in a ticket position, it absolutely cannot grant itself permission to write data. It's just context. No authority whatsoever.
Contrast that with a mode. A mode is a server-defined AI Fabric capability bundle. It lives securely on the server, totally out of reach from the client. For instance, a mode called support_assistant might enable retrieval but completely disable actions. Another mode, like support_resolver, might enable both. Modes are super powerful. They can constrain vector spaces, limit document budgets, manage context size, all of it, and they are strictly controlled. The server uses allow lists and ai.orchestration.modes. So, if strict mode routing is enabled, an unknown mode doesn't just quietly default to something else. No way, it fails visibly.
And this brilliantly illustrates the difference side by side. Your application owns the position using your app's vocabulary, like knowledge. But the server strictly dictates and enforces the mode, like support_assistant. Simply put, your application owns where the user is, but the server enforces what the AI is allowed to do in that place.
Section 3. The ownership boundary. Mapping responsibilities.
What's really fascinating about this architecture is how cleanly it separates concerns. The application is responsible for mapping its own position vocabulary. It knows what checkout means. Then we have the AI Fabric core. The core stays completely application neutral. It doesn't care at all what ticket means. Its only job is to enforce the selected server mode that the application maps to. Finally, we have security. Security controls remain entirely separate from this routing logic. This means your AI routing doesn't accidentally become your security bottleneck. It's a really elegant separation.
Section 4. Orchestration Policy and Precedents. The routing logic.
So, how does AI Fabric actually know which mode to apply? Well, it follows a strict precedence. Step 1. If a request explicitly asks for an approved mode, the application preserves it and the core validates it against the allow list. Step 2. If no mode is supplied, but there is a known position, the application maps that position to a specific mode. Step 3. If neither is supplied, the server default kicks in. But what happens if an unknown position is sent when strict routing is enabled? It fails right at the application boundary. This clear precedence makes diagnostics a breeze. Your policy metadata can explicitly report the effective mode, the position, and the action gates for every single request.
Section 5. Concrete Flows and Failures. Putting it to the test. Okay, I want you to picture this exact message hitting your endpoint. Create a ticket about missing recovery emails. That is a crystal clear intent to perform a write action. So how does AI Fabric handle this based on where the user is?
Let's trace it.
First scenario, the user is sitting at the knowledge position. The AI model gets the prompt and emits a structured action intent because, well, it wants to create the ticket. But look at what happens. AI Fabric intercepts this and returns clarification underscore required with the reason actions disabled by policy. This is huge. The model literally cannot override the server-defined mode. Even if the AI desperately wants to help the user take an action, the mode acts as a hard server-side boundary and just shuts it down.
Now, let's flip it to the second scenario. The user is at the ticket position. The application maps this position to the support resolver mode, which actually does allow actions. AI Fabric discovers the typed action, resolves the trusted account context, and then returns confirmation required. But notice what it didn't do. It didn't just execute the action. The action has merely been discovered and staged. Confirmation and authorization are still absolutely mandatory. The mode allowed the discovery, for sure, but separate security controls still govern the actual execution.
To really nail this down, the source material points out a few things you absolutely should not do. First off, never accept arbitrary mode names from JavaScript. If your client can just send over a mode called admin and get powerful behavior, your system is already compromised. Second, please don't put never execute actions in your system prompts while leaving actions enabled in the backend. You're relying on a probabilistic language model to enforce deterministic security, which is pretty much a disaster waiting to happen. The correct design always relies on strict, deterministic server-side mode routing.
And because we use that deterministic routing, we get highly visible failures. If a browser tries to send an untrusted admin mode, the core immediately returns an unsupported mode error. If it sends an unknown position without a mode, the application rejects it with an HTTP 400. There are zero hidden fallbacks here. The system doesn't just quietly downgrade to some default vulnerable state. It fails loudly, which keeps your architecture secure and your debugging incredibly straightforward.
Section 6. The Prod 02 Lab Bridge. Your turn to build.
All right, for the Prod 02 Lab, it's your turn to get hands-on. You're going to configure both the Support Assistant and Support Resolver modes. You'll implement the Support Mode Resolver to handle that application-to-core mapping we talked about. You will extend your requests with bounded, optional routing fields, and crucially, you're going to prove every single branch of this logic through the real orchestration pipeline. After that, you'll rerun all your earlier action and memory tests, just to guarantee that this new strict policy hasn't accidentally broken your existing framework behavior. I want to leave you with one final thought as you head into the lab. If your AI framework quietly hid unsupported modes behind default fallbacks instead of failing visibly, how many untrusted actions would execute in production before you even noticed? By strictly separating positions from modes and enforcing a rigid orchestration policy, we ensure the answer to that question is always zero. Happy coding, developers, and I'll see you in the next explainer.